to everyone, I'm Leong Cheng Yee and my supervisor is Dr. Ling. So now, I'm going to present on my research with the title of Polydimethysiloxane coated, Chitosan modified, silver titanium dioxide nanoparticles photocatalyst for antibacterial and antifungal activities. So the aim of this research is to synthesize a new antimicrobial agent to combat the antimicrobial resistance global issue in this century. So it is actually a global health threat, and according to the Ministry of Health, Malaysia is not spared from this hazard. So do you guys actually know that the bacteria are highly transmitted in the environment, especially in an area with high humidity? Based on the analysis done by the World Health Organization, there are 7 million people killed by the air pollution annually and 23% of the global death due to the environmental pollution. So, to cure the bacterial infections, antibiotics are used. However, the appearance of the antibiotic-resistant bacterial strain is rising to a threatening level in these recent years due to the misuse and overuse of antibiotics. So, other than the bacteria, fungi could be harmful to the human health as well. Therefore, in order to eradicate the aforementioned problem, a new antimicrobial agent to be synthesized in this study will be able to be sprayed or coated on the surfaces where the traditional cleaning is not possible, as well as on the surfaces that requires the potential inhibition of the bacterial adhesion, such as the doorknobs, as well as the privacy curtains in the hospitals. So basically, the concept of the antimicrobial agent to be synthesized in this study is the superhydrophobicity of the antimicrobial agent induced by the PDMS coating, the polydimethylsiloxane coating, will be able to inhibit the bacterial adhesion on the surface. But just in case the bacteria or the fungi penetrate through this first layer of protection, the second layer, made up of the Chitosan modified silver doped Tl2 nanoparticles, will be able to kill the bacteria or the fungi that penetrates through the first layer of protection. So the main challenges to synthesize this antimicrobial agent is the usage of the Tl2, the titanium dioxide nanoparticles, as the substrate, as Tl2 has been reported to have the wide band gap energy and a fast electron hole recombination rate that causes it to be active under the UV irradiation only. So to solve these problems, silver will be used as the dopants in this study to act as the electron trap to retard the photo-induced electron hole pair recombination rate, as well as to promote the surface plasmon resonance effect. So, how do we induce the antifungal activity in the antimicrobial agent? And in this case, Chitosan will be used, as it has been reported and well known as an excellent fungicide. So it is worth noting that the antimicrobial agent to be synthesized in this study is active under the visible light irradiation, means it is active under the normal room condition, and most importantly, it is non-toxic. While the traditional synthesis of the material requires the high temperature calcination in the soil gel method, in our study, a low temperature will be used for the material synthesis via the soil gel method, followed by the baptization reaction. All in all, the preliminary result of this research has shown a positive outcome. The lower band gap energy and the slower photo-induced electron hole pair recombination rate has allowed this research to be workable. And the future work of my study will be on the addition of the PDMS coating to induce the superhydrophobicity of the agent, of the antimicrobial agent, and then later, antimicrobial testing will be conducted on this synthesized material using the gram-positive and the gram-negative bacteria as well as the fungi. And that's all from me. Thank you.